In the last time we talked about logarithms and indices and logarithms, but today we'll be looking at another topic entirely called simultaneous equations. These are equations you'll be solving two different equations at the same time, where you have two different variables in each equation. And after this, we'll also be looking at how to solve simultaneous logarithmic equations. So we'll be looking at simultaneous equations first before we go into simultaneous logarithmic equations. Let's have this as examples. Examples. Let's have this as number one. Question. 2x plus 2y equals to 3. Then we have another one. 2x minus 2y equals to 5. How do you solve these particular equations? These are two equations. You have to solve them at the same time. That is why they are called simultaneous equations. But how do you solve this equation at the same time? How do you solve them? For simultaneous equation, we have three different methods of solving simultaneous equations. We have the elimination method. We have the elimination method. We have the elimination method. We have what we call the substitution method. Substitution method. And we also have what we call the graphical method. The graphical method. Now, each of these methods, when you use them for any simultaneous equation, you will get the same answer, the same values for x or y and y, or a and b, c or d, whatever variable is in the equation. You have variables you have in the equation, you get the same answer when you use any of these methods. So if you decide to use elimination method and some other person decides to use substitution method, you will get the same answer. Now, how do we use this? How do we use this and how do we use this? But basically today we'll be looking at this and this, because this involves the use of graph. We could also do it without using graph, but we would limit our discussion to elimination method and the substitution method. Please take notes in your exams. Nobody will ask you to use a particular method. So long as simultaneous equations are concerned, nobody will ask you to use a particular method. You decide which one you want to use to solve the equations. Whatever value you get for x and y, if you fix them in here and in here, you get this. Meaning that this right hand side, this left hand side will be equal to this right hand side. Now we'll be using the two methods here. I will use the elimination method here and I will also use the substitution method here. So we compare the answers and see that they are the same thing. Now, how do we use elimination method? How do we use elimination method? We are trying to use the elimination method now. We are trying to use the elimination method. The essence of using these two methods is just to point out that whatever method you use, that you will get the same answer, the same value for x and y. That is it. Nobody will force you, the examiner will not force you to use a particular method. Whatever method you think you like, you find easier, you can use such method. Now, how do you use the elimination method? Now look at this question. 2x plus 2y, 2x plus 2y equals to 3. We call this equation 1. And we have 2x minus 2y equals to 5. We call this equation 2. And there is something we do in elimination method. Elimination means to remove something. To eliminate means to remove something. Now, we are trying to remove one of these variables. And how do we remove the variables? That is what will lead us to elimination. That is, how do we eliminate now? Look at this equation. 2x, y, and then the other side. For example, if this question says 2y plus 2x equals to 3, and this one says 2x minus 2y equals to 3, you have to try to rearrange the equation so that we have x here and x here, y here and y here. So that we have x here and x here, y and y here. So you have to rearrange it without changing anything so that we have the same variables here and here and here and here. Then how do we eliminate? That is the question. How do we eliminate? How do we eliminate either x or y? To eliminate now, this is 2x. 2 is what we call the coefficients of x. X is a variable. Like here too, 2 is the coefficient of y, of 2y. Y is the variable. Now, how do we eliminate? This is 2 here, this is 2 here. We say equation 1 multiplied by 2 because we have 2 here. Assuming we have 3 here, we multiply all of equation 1 by 3. Multiply all of equation 1 by the coefficient of this in equation 2. Multiply equation 1 times 2. And then also, because we have 2 here again, multiply equation 2 times 2. Assuming we have 4 here, we would have used 4 to multiply everything here. I mean everything in equation 2. So what do we get now? We get a different set of equations. 2 times 2x gives 4x plus 2 times 2y plus 4y equals to 2 times 3 gives us 6. Don't forget, we are using the coefficient of equation, what we have in equation 2, the first thing we have in equation 2 to multiply everything in equation 1. And then we are also using the coefficient of what we have here to multiply everything in equation 2. Let's do this too. 2 times 2x gives us 4x. 2 times minus 2y gives us minus 4y equals to 2 times 5 gives us 10. At this point, we do what we call subtraction. Minus. This gives us equation 3 and this gives us equation 4. Now we are subtracting equation 3 from equation 4 from equation 3. Now this equation 3 minus equation 4. This equation minus this equation. You can see by multiplying this by the variable of 2x here, we have a different set of equations. Now 4x minus 4x gives us 0, nothing there, plus 4y minus 4y, this is it, plus 4 plus 4y minus 4y. Now you have two signs beside each other. 4y minus times minus gives us plus 4y. So 4y plus 4y gives us 8y equals to. Don't forget, don't just use this minus at this point and forget using it here and there. 4x minus 4x is 0, nothing. 4y minus 4y. 4y minus 4y gives us 8y. Then we have again 6 minus 10. You continue to use this minus throughout your subtraction. 6 minus 10 gives us minus 4. 6 minus 10 gives us minus 4. At this point we are having x 8y equals to minus 4. Then divide both sides by y. Our y then equals to minus 4. Divide both sides by 8 rather. Our y then equals to minus 4 all over 8. Our y equals to minus 4 all over 8. 2 here, 4 here, 1, 4 here, 2. Therefore, y equals to minus 1 over 2. Or if you want, or you can say minus 0.5 if you decide to put this in decimals. So the value of y is minus 1 over 2. The value of y is minus 1 over 2. Now, how do we get x? We have gotten the value of y. What do we do next? What we do next is what we say, substitute for y in any of these equations. Now we are going to substitute for y in either 1, 2, 3, or 4. In either equation 1, equation 2, equation 3, or equation 4. Substitute for y. Substitutes for y in equation, you can use any equation you like. Whatever equation you use, you get the same value for x. So let's substitute for y in equation 2. You can use any equation you like. So equation 2 says 2x minus 2y equals to 5. 2x minus 2y equals to 5. Now we've gotten the value of y. We've gotten the value of y to be minus 1 over 2. Or if you decide to use decimals, minus 0.5. Now, 2x, now we put in the value of x into the value of y into this equation. 2x minus 2, our y now is minus 1 over 2. Minus 1 over 2. Minus 1 all over 2. Our y now is minus 1 all over 2 equals to 5. 2x minus 2, our y now is minus 1 all over 2 equals to 5 on the other side. 2x equals to, first, minus times minus gives us, 2x minus times minus gives us plus 2 times 1 over 2. These two will only multiply the numerator, not the one down, not the denominator. So 2 times 1 gives us 2 all over 2. For example, 2 times 3 over 4 will give us 2 can only multiply 3. That is up, not the denominator. 2 can only multiply 3, which gives us 6 all over 4. So minus times minus gives us plus 2 times 1 is 2 all over the denominator 2 equals to 5. That's what we have. Now let's break it down. 2x plus 2 divided by 2. 2 over 2 gives us 1. 2 over 2 gives us 1 equals to 5. Just looking for x. 2x equals to 5. I told you the last time, whenever you are moving any number or any value across the equality sign, I call it the red C. So we are moving this plus 1 across the red C, we are going to be having minus 1. It becomes minus 1. But when you are not moving across any red C, that is the equality sign, don't change the sign of that value. The initial sign has to remain like that. So we are moving minus 1 across the equality sign, it becomes, we are moving plus 1 across the equality sign, it becomes minus 1 on the other side. Therefore, 2x equals to 5 minus 1 gives us 4. 5 minus 1 gives us 4. Now we are looking for the value of x. X then divided by side by 2 equals to 4 all over 2. X equals to 2. The value of y is minus 1 over 2, and the value of x is 2 in this equation. And if you check, if you put these values of x and y into any of these equations, you get this, or this. That's what you will get using the elimination method. Using the elimination method. First, you must eliminate one of the variables. In this case, now we eliminated x here by subtracting equation 3, equation 4 from equation 3. And then we are left with y. We got the value of y, and then we have to substitute for y in equation 2. If you like, you use equation 1, use equation 2, 3, and 4 to substitute for the value of any other of the other variable. So that is that about the use of elimination method. Okay, now we've gotten the values of x to be 2 and y to be -1/2 using the elimination method. Now let's try the substitution method and see if you're going to get the same values for x and y. Using the substitution method now. Solution. Now we are using the substitution method. Now how do we substitute? Let's write out our equation. Equation 1, 2x plus 2y equals to 3. And equation 2, 2x minus 2y equals to 5. This is equation 1 and this is equation 2. Now how do we use this method? Unlike the elimination method where we have to eliminate a particular variable before we can get the other one. In this case, we don't have to eliminate any variable. Now, you choose between equation 1 or equation 2. Choose between equation 1 and equation 2. Which one you would like? Okay, in equation 1, I want to find y in equation 1. And then, or equation 2, I want to find x in equation 2. Now, we can say, now, I want to use equation 1. And I'm saying that from equation 1, some other person might decide to use equation 2. From equation 1 says 2x plus 2y equals to 3. Equation 1 says 2x plus 2y equals to 3. From equation 1 now, I want to look for y. I want to look for y in equation 1. That's what I want to do. Then I will say 2y equals to 3 minus 2x. 2y, that is what I want to do. If you decide to look for x, you say 2x equals to 3 minus 2y, because this plus 2y changes to minus 2y across the red C, the equality sign. Now, what I'm looking for is 2y. I might decide to use 2x. I'm looking for y rather. So 2y equals to, this 3 is here waiting for 2x to come. 2x is the same thing as plus 2x. So it crosses to the other side and becomes minus 2x. Now, we are looking for y. Y equals to, though we are not getting a specific value for y yet, but we are working with this to get the value of y and the other value of x too. So 3 minus 2x all over 2. We are looking for y. So the value of y is 3 is equal to 3 minus 2x all over 2. That is what the value of y will give us. But that is not a specific value for y. It's not a specific value for y yet. So we are going to look for the value of y from here. You can decide to use the x as I said earlier. 2y equals to 3 minus 2x. Y then equals to 3 minus 2x all over 2. So, what do we do now? Put this value of y in any of the two equations. Put this value of y in either equation 1 or equation 2. Put y equals to 3 minus 2x all over 2. That's the value we have for y here in any of those equations. Now, we are going to put this in equation 2. Why we are going to put it in equation 2 is because this y equals to 3 minus 2x all over 2. Sorry, I made that mistake there. Y is equal to 3 minus 2x all over 2. We derived it from this first equation. So when you put it back into this, you still be getting the same thing. So you put it in the second equation. You don't put it back in equation 1, rather you put it in the second equation. So put y equals to 3 minus 2x all over 2 in equation 2. You cannot put it in equation 1 back. Just like what you have taken, you are returning to the place. So we don't do that. Rather, you put it in the other equation because we derive y equals to 3 minus 2x over 2 from equation 1. So we are going to put that value into equation 2. So equation 2 says 2x minus 2y equals to 5. But our y is 3 minus 2x all over 2. So let's put in the values. 2x minus 2. Our y is 3 minus 2x all over 2. 3 minus 2x all over 2. 2x minus 2y, our y now is 3 minus 2x all over 2 equals to 5. That's what we have. Let's break it down. 2x minus, now this multiplies the numerator, like I said earlier, not the denominator. So minus 2 times 3 gives us minus 6. Minus 2 times minus 2x, minus times minus gives us plus. 2 times 2x gives us 4x all over 2 equals to 5. Using your LCM now, which is 2. Using your LCM, which is 2. So our LCM here is 2. By multiplying through by the LCM, which is equal to 2. The LCM is 2. So multiply this by 2, multiply this by 2, and multiply this by 2. 2 times 2x gives us 4x. 2 times 2x gives us 4x. 2 times all of this, that is 2 times 6. 2 times minus 6 plus 4x all over 2. We are using 2 to multiply this, the LCM which is 2 to multiply this, and to multiply that. So 2 cancels 2, we are left with minus 6 plus 4x. Minus 6 plus 4x equals to 2 times 5 is what? 10. We are multiplying through, multiplying everything by the LCM. Our LCM is 2. So 2, that 2 times this gives us 4x. 2 times the whole of this, that is minus 6x plus 4, minus 6 plus 4x all over 2 times 2, because we are multiplying through by the LCM. 2 cancels 2, we are left with minus 6x plus 4x. Minus 6 plus 4x equals to 2 times 5, 10. So let's correct like terms here. 4x plus 4x gives us 8x minus 6 equals to 10. Then we have 8x equals to 10. Minus 6 crosses the red C, the equality sign, it becomes plus 6. So 8x equals to 10 plus 6 is 16. 10 plus 6 is 16. Now we look for x. X dividing both sides by 8, which is the coefficient of x. X equals 16 all over 8. Then x is 2. We have gotten the value of x now to be 2 using the substitution method. The value of x now is 2 using the substitution method. Now we are still going to get y. Let's go again to how we got x. Between the two equations, you can decide, okay, you want to say from equation 1 or you want to say from equation 2. You can decide which of the equations you would like to solve from, to derive a value from. Though not a specific value yet. Now in equation 1, I decided that I wanted to use equation 1. 2y, I wanted to bring y out. 2y equals to 3 minus 2x from equation 1. Then y equals to 3 minus 2x all over 2. Put y, which is 3 minus 2x all over 2, in equation 2. If I had derived y equals to 3 minus 2x over 2 from equation, if I had derived that from equation 2, I would put this value in equation 1. But because we derived it from equation 1, we put the value in equation 2. Please take note of that. So we are putting the value of y equals to 3 minus 2x over 2 in equation 2, not equation 1. Now, equation 2 says 2x minus 2y equals to 5. So let's fill in the values. 2x minus 2y. Our y now is 3 minus 2x all over 2. That is what we have in brackets. Equals to 5. 2x minus. Now, minus 2 times 6 gives us minus 6. That's what we have. Minus times minus gives us plus. 2 times 2x gives us 4x all over 2. I told you, 2 we only multiply the numerator, the one that is up at the top. That's what we call the numerator in a fraction. The one beneath is what we call denominator. So this times this gives us all of this all over 2 equals to 5. We have something like this, you simply find the LCM. The LCM here is 2. So multiply through by the LCM, which is equal to 2. The LCM is 2. So multiply everything here, here, and here by 2. The LCM. 2 times 2x gives us 4x. 2 times all of this gives us minus 6 plus 4x equals to 2. Equals to 2 times 5 gives us 10. So 4x plus 4x gives us 8x. Minus 6 equals to 10. 8x minus 6 equals to 10. Minus 6 crosses to the other side because we are collecting like terms. It crosses the equality sign, which I always call the red C, and becomes plus 6. So 8x equals to 16. Value of x equals to 16 all over 8. So 16 over 8 gives us 2. We have gotten the value of x. Now let's look for the value of y. We're going to look for the value of, we've gotten the value of x already to be 2. Let's look for the value of y. Then we say substitute for x in, now you can substitute for x in any of the equations, whether 1 or 2. In this case, let's use equation 1. Equation 1 says 2x plus 2y equals to 3. That is equation 1. Equation 1 says 2x plus 2y equals to 3. We've gotten the value of x already to be 2. So now we are substituting for x in equation 1. You can use equation 2 if you like. So 2x, our x there is 2. 2 plus 2y equals to 3. You don't have to go back to the value of y where we got 3 minus 2x equals to over 2. No. You don't have to go back to that. That is not a specific value for y. We are looking for a specific value for y. So 2x plus 2y equals to 3. Our x now is 2. Then we go again. 2 times 2 gives us 4 plus 2y equals to 3. 2y equals to 3. Now 4 wants to cross the equality sign. It becomes minus 4. 4 is the same thing as plus 4. So it becomes minus 4 on the other side. So 2y equals to 3 minus 4. 3 minus 4 gives us minus 1. 3 minus 4 gives us minus 1. We are still looking for y. Then y equals to minus 1 all over 2. Y becomes minus 1. Y becomes minus 1 all over 2. So the value of x is 2. The value of y is minus 1 all over 2. The same answer we got. using the elimination method is the same answer we get here. X is 2, y is minus 1 all over 2. That is how to solve simultaneous equations. It's as simple as that. Using the elimination, using the graphical, or using the substitution method. Even if you use the graphical method, you will still get the same